Have you ever just looked up at the night sky and wondered? About that giant glowing rock up there, the weird rhythm of the oceans, or all those patterns scattered across the darkness? Well, today we're going to connect those dots. We're going to see the simple, kind of beautiful rules that run our little corner of the cosmos.
I mean, it's one of the first big questions we ask as kids, right? It's the perfect place to start. One night, the moon's this perfect bright circle. The next, it's just a sliver. And then sometimes, poof, it's gone. So what is actually going on up there?
All right, here's the big secret. The moon isn't changing at all. Not really. The whole thing is about perspective. Our perspective, right here from Earth. What we see is basically a trick of the light, a huge cosmic shadow play starring the sun, the moon, and us. Okay, so think of the moon like a giant, dusty mirror hanging in space. It doesn't have a light switch of its own. That beautiful glow is just sunlight bouncing off its surface. So these phases we see, that's just us seeing different amounts of that sunlit side as the moon makes its monthly trip around our planet.
It all kicks off with the new moon. Now, the moon is still there, but it's hanging out between us and the sun. That means the side that's all lit up is facing completely away from us. From our point of view, it's pretty much invisible.
Fast forward about a week, and we get the first quarter. The moon's moved, well, a quarter of the way around its orbit. Now we're getting a side view, so we see exactly half of the sunlit part. It looks just like a perfect half circle. And then, the main event, the full moon. This is the one we all know and love. In this phase, we, the Earth, are positioned right between the sun and the moon. And because of that lineup, we get a full, head-on view of the entire sunlit face. It's the brightest and boldest it's gonna get. And as the moon keeps cruising along on its orbit, we get to the third quarter. So again, we see exactly half of the sunlit part, but now it's the opposite half from the first quarter. And from here, the light's gonna start shrinking every night, heading back to a new moon. And here it is, the whole dance in one picture. See? The sunlight is always blasting from one direction. As the moon circles the Earth, our angle on that sunny side is constantly shifting. And that's it. That's what creates the totally predictable, month-long cycle of phases. And hey, if you want to sound like you know your stuff, here are the 2 words you need. When the slice of light is getting bigger each night on its way to a full moon, we say it's waxing. And when the light is getting smaller, heading back to a new moon, it's waning. It's that simple. Waxing on, waning off. But the moon does so much more than just look pretty. Its influence is so powerful it literally pulls our oceans around. So let's dive into how that same cosmic dance connects the moon's phases to the rhythm of the tides. So what are tides exactly? Well, to put it simply, they're the daily rise and fall of sea level along the coast. It's a massive movement of water, kind of like the whole planet is taking a slow, deep breath, all thanks to the pull of gravity. Now, it's not just the moon in on this game. The sun's gravity is a huge force too, of course. Both of them are in this constant gravitational tug-of-war with Earth's oceans. But the question is, who wins? So, who wins that cosmic tug-of-war? Well, even though the sun is an absolute monster, way, way bigger than the moon is just so much closer to us. And when it comes to gravity, proximity is everything. It means the moon's pull on our tides is actually about twice as strong as the sun's. The moon is the undisputed champ. Okay, little pop quiz for you. We know the moon has the strongest pull, and the sun has a pretty decent secondary pull. So what do you think happens when their gravity teams up? When the sun, the moon, and the Earth all get in a straight line. Well, that perfect alignment creates what we call spring tides. With both of their gravitational forces pulling together, they produce the most extreme tides. We're talking very high tides and very low tides. But when the sun and moon are at a right angle to us, their gravity is kind of working against each other, and that creates much weaker, more moderate tides called neap tides.
And check this out. This connects perfectly back to what we just learned. Those extreme spring tides, they happen during the new and full moons. The exact times when the sun, Earth, and moon are all in a line. And the weaker neap tides, they happen during the first and third quarter moons when they make that right angle. It all just fits.
So, you might be wondering, why does this happen twice a day? Well, this part's a little wild. The moon's gravity actually pulls the ocean into a bulge on the side of the Earth facing it and on the side opposite it. So as our planet spins through these 2 water bulges each day, most beaches get 2 high tides and 2 low tides. It's this steady, 4-beat rhythm, all set by our planet's spin and its loyal moon.
Okay, for our final act, let's zoom out. Way out. Beyond our moon, beyond our sun, all the way out to that huge canvas of stars that has been guiding and inspiring people for as long as we've been around to look up.
I mean, long before we had GPS or even paper maps, the stars were it. They were our guide. Ancient cultures all over the globe saw the exact same stars we do, but they all connected the dots in their own ways, creating these patterns, constellations, that told stories of their gods, their heroes, their monsters. It was the original storybook of the sky.
And here are two of the most famous characters from that storybook, at least for us here in the Northern Hemisphere. On the left, you've got Ursa Major, the Great Bear, which has the famous Big Dipper inside of it. And on the right, you've got its smaller buddy, Ursa Minor, the Little Bear.
But these are way more than just pretty pictures. They're a map, a working map. If you can find the Big Dipper, you can always find north. You just find the two stars at the end of the bowl, follow them in a straight line, and boom, they point you right to Polaris, the North Star. And what do you know? Polaris just happens to be the very last star in the handle of the Little Dipper. Pretty cool, right?
And the whole sky is just jam-packed with these incredible patterns. You might spot Pegasus, the mythical winged horse, galloping across the sky in the fall. The more you look, the more you start to see. And once you recognize them, the night sky stops being this random jumble of lights, and it turns into a familiar, friendly map.
So from the changing face of our moon, to the rhythmic breath of our oceans, all the way to the ancient storybooks written in the stars, it really is all connected. It's one big cosmic dance, and we have a front row seat. The only question left is, the next time you look up, what stories will you find?